Hello, this is Peter from Educomondo and a warm welcome to our STEAM project number 7 called The Buzzing Bee. This is the teacher edition, in which we pay more attention to technical explanations. We also give pedagogical tips in order to make your STEAM lessons fun and exciting. I want to remind you that this is for the absolute beginning STEAM teacher. We call this level the Explorer level. In this lesson, we are going to introduce a new component to our class, the buzzer. The first thing to explain is that there are two types of buzzers, active and passive ones. You will find both in the starter STEAM kit. It can be a bit confusing as both buzzers look very similar. Let us first look at the physical differences between the two types. When new, the active buzzer has this paper cover. The text "remove after washing" doesn't mean you have to give it a bath. In this context, washing refers to the removal of soldering residue. Another distinction is that the active buzzer is sensitive to its polarization. To make this clear, the positive leg is longer than the negative leg. And just as with an LED, your students have to be aware of this polarization in order not to damage the buzzer. The other distinction is the color of the underside. When the underside is black, it is an active buzzer. When it is greenish, it is a passive buzzer. Let's have a look at the functional difference. The active buzzer is able to vibrate on its own by simply connecting it to a power source. The passive buzzer will need a signal from the outside to produce a sound. Now you can explain in simple terms what the basic operating principles are. To make it clear, we have opened the buzzer so you can see what is inside. A buzzer consists of 1. A thin metallic membrane with a metal weight on top of it. 2. A small coil around the core. And 3. A fixed magnet. When applying a voltage, a built-in transistor operates as an oscillator, powering the coil on and off. This produces an electromagnetic force pulling on the metal membrane, causing it to vibrate. This fast vibration creates waves in the air, which is the sound that we hear from the buzzer. The purpose of today's project is to build a simple circuit to make a buzzer sound like a bee. First, we will do some programming as the active buzzer in the project. We will rehearse the use of variables and the commands pin mode and digital write. And, as always, we will do some smart fault finding and troubleshooting where necessary. Let's distribute the components to your students. The microcontroller and the breadboard, one active buzzer, two jumper cables, a red and a black one to be aligned with the standard color coding for positive and negative, and let us not forget the most important part, the cardboard bee. If your class has soldering mats like the blue one that I am using, put the components into the boxes. It will help your students not to lose the electronic components, and it will also enable them to work in an orderly fashion. Show your students this image. It will help them to put the components in the right places. You can leave this drawing on your computer in front of the class or project it on a wall or whiteboard. It is a quite simple setup, and by now your students should be able to build this quickly. The legs of the buzzer are not that long, but they are quite strong, so it shouldn't be a problem to push them in the breadboard. Because the buzzer is pushed deep into the breadboard, it's typical to lose sight of what is the positive or the negative leg. Make sure your students take good notice of their positions. Next, we are going to connect the buzzer to one of the digital pins. For this exercise, we are going to choose pin number 10 and connect the red cable to the positive side of the buzzer. The black cable is used to connect the ground pin to the negative leg of the buzzer. Let your students open the Arduino Integrated Development Environment and create a new sketch called Lesson 7 BuzzBee. When all of that works and the students have responded positively to you, ask them to think about what the programming should do. Remind them of the commands that they used in lesson number 2, the eye of the dino, to make the LED blink. We are going to use the exact same commands. Let them try on their own for 5 or 10 minutes, but let them not yet run the program. We will do the programming together. By now, they know to put the commands at the top of the program and add the name of the project and the variables. Project 7, BuzzBee, / variables. First, we declare our digital pin as a variable called buzzPin. Because we put our red cable in pin number 10, we type int buzzPin equals 10. We also declare a delay variable called dt and give it a value of 500 milliseconds. int dt equals 500. In the setup area, we set up the buzz pin as an output by using the command pin mode buzzpin output. And in the loop section, we use the command digital write buzzpin high followed by a delay dt, and then we set our pin to low again. And we close with another delay. Check with your students whether they were able to write the program. Help those who have encountered some issues. Now it's time for them to upload their code. The class should be filled with sounds of the buzzers. Although the active buzzer can only play one sound, you can experiment with changing the delay time. Let your students play around with different delay times and ask them what is happening. If it doesn't work with some of the groups, tell them not to panic. Tracking and correcting errors is one of the most important skills in programming. Encourage them to do some logical fault finding by asking the following questions. Did you end all commands with a semicolon? Did you spell all commands correctly? Did you put the wires in the right pins? Did you declare the right pin number as a variable? Are all connections on the breadboard firm? Is the buzzer not broken? This concludes our project number 7, the buzzing bee. Time to look back at what we learned. First, we introduced a new component, the buzzer. We also talked about the difference between the active and passive buzzers, both functionally and physically. We taught our students how to program the active buzzer. And we did that by rehearsing the use of variables and the commands pin mode and digital write. And in the case where it was needed, your students exercised their ability to do some smart fault finding and troubleshooting. Because we experimented with buzzing bees, wouldn't it be a great idea to have an assignment involving these wonderful small creatures? Bees are a great topic for your students to do research on, and you can give them many assignments. Here are a couple of possible questions that you can start with, but do use your own creativity or maybe something from the local news as a starting point. Find 3 reasons why you should not be afraid of bees. Why are bees so important? What is the difference between a bee and a wasp? On a global scale, less and less bees are around. What happened, and is there something that we can do to stop this decline? Research has shown that bees communicate with each other by dancing. Can you find some examples and explain what it means? Have fun with the assignment. I hope that you and your class enjoyed this lesson, and I'm eager to start with our lesson number 8. In that lesson, we will work with the passive buzzer. A passive buzzer is more versatile than an active one because you can change the tone of the buzzer. And when you can change the tone, you can play a melody, like a bird singing happy birthday. Bye-bye for now.